So this was a weekly homework exercise that was related to SI quantities, graphs and the motion. Any doubt on page number 2? Page 2, any doubt? This was a last week homework, SI quantities, graph and motion. Any doubt? If no doubt, then we'll move on. Page 3, any doubt? Page number 3, any doubt? Question 3, okay. Question 3 is the same one we just discussed now in the momentum part. Page number 4, any doubt? Page 4. For any question on a page, if you have doubt, feel free to ask your doubts. Question 8. For those students who are having a computer class today at 3, you can leave the session as you have a test today. So you can check the recording because I will discuss only the doubts today. In case if you have doubt, you can just mention your doubts and leave the session. I will record. The difference between gravitational field and field. Yes, I will discuss that. Just after discussion of the doubt, I will come back to the point, the difference between the field and gravitational field. Question 8. A football is kicked at a speed of 12 meters per second at an angle of 35. So, horizontal component. So, a football is kicked at a speed of 12 meters per second at an angle of 35 to the horizontal. So, it will have two components. One of the component is with an angle. So, if the component is with an angle, this will be 12 cosine 35. And one of the is opposite to the angle, that will be 12 sine 35. But we need the horizontal one. So the horizontal one should be 12 cosine 35. So A should be the right answer. And about the marking schemes, like for every pop quiz assignment, there is a marking scheme. Once you submit, you can just ask me on WhatsApp for the to have the marking scheme for that specific test or quiz. I will share because usually I forget about sharing the marking scheme. So you can ask once you submit any exercise or the pop quiz, you can ask for marking scheme, and I'll share. Question 5, any doubt? Sorry, page 5, I mean. Okay, in this one, question number 10. Question number 10, a student carried out an experiment to measure the acceleration of a free fall. The ball bearing was released from a position A, and the time for the ball bearing to fall a distance L is measured. And this was repeated by decreasing the values for L. How would you measure the how the measurements obtained can be used to determine the acceleration due to gravity? And your answer should include a sketch on the axis below. Look, what is the initial velocity for falling object? Initial velocity is 0. We are measuring a distance and we are measuring a time. So if we use this equation, we have S is equals to ut plus half at square. If the initial velocity is 0, so s is equals to half, because this factor will be 0. So s is equals to half at square. And if we substitute s is a distance traveled, so that will be length. It will be half. Acceleration is due to gravity g and t square. Then we compare with the equation of straight line, y is equals to mx. So on y-axis, if I plot the length in meters, on x-axis, if I plot, so on y-axis, if I have the length in meters, on x-axis, if I have a time square, so first thing, it will be a straight line. Why it is a straight line? Because as you can see, the gradient is half g. So g is constant, half is constant, so it must be a straight line. And that straight line should pass through the origin because there is no y-intercept, like there is no quantity added here. So it will be a straight line passing through origin. So the gradient of this graph will be half g. And if I need g, so twice the gradient will be equals to g. And then you just have to mention how to measure, like by using a scale or a ruler, you will measure the length, and the timer you recorded by, the timer will record the time, and you plot a graph between the length on the y-axis and the time square on x-axis, and the gradient will be equals to twice the g. Is it clear, this one? Yeah, to measure the length, use a meter rule, and the timer is recorded by using a timer, and then which quantity you plot a graph and how you work out the expression due to gravity. Tape measure you can mention, but it is usually less than a meter. So you can mention tape measure, that's also fine. Page number 6, any doubt on page 6? Question 13. The velocity time graph for a motion of a ball is shown. Which of the following correct describe the motion of the ball? First thing, the ball speed is increasing. Okay, so it means the ball is being dropped. That's why the ball speed is increasing. Then the ball bounced back, but you can see the speed at which it hits is higher than the speed at which it bounced back. So what this given indication? It is given indication that the ball will not return back to the same position. If, like example, the ball is hitting and it hits the ground at a speed of 3 meters per second and bounce off with the same speed, 3 meters per second, it means in this case, the ball should have the same height. It should reach the same height. But the ball does not reach the same height. What it shows how we can say from the speed at which it bounced back is different from which speed at it hits. So definitely some of the energy is lost, so it won't rise to the same height. So the ball is dropped and rebound to the original position? No. The ball is dropped and rebound to lower position? Yes. The ball is thrown upward. Why thrown upward is not correct? Because when I throw something upward, what should happen to the velocity? The velocity should decrease. Means the graph should start from a maximum value and then it should decrease. But the graph is starting with a minimum value. So that's why the ball is not thrown upward. Both are wrong. So B will be the right answer. Is it clear? Page 7, any doubts? Page 7. Question 14. In question 14, which of the following graphs of a displacement against a time could represent the motion of the ball? This is actually related to this part only, because it's like motion of the ball is there. So you have a velocity time graph and you need a displacement time graph. So first, what is happening to the velocity? The velocity is increasing, the first part, okay? And it is positive. What about the second part? The velocity is negative, okay? And it is decreasing as well. Like, because you can see, say this value was say -2, then the next value will be -1 and then 0. So the velocity, like one half of the motion, the velocity value is increasing and it is positive. And the other half of the motion, the velocity value is decreasing and it is negative. Now we have to check a displacement time graph, the slope. When you check the first one, the slope, because you have to check the slope, the first part of a motion, this is y1, this is y2. Yeah, I'm coming to that point. Y1 and y2. So y1 is above y2, so y2 is above y1, so it means it is positive. And what happened to the slope? The slope is increasing. So it matches with our first description. What about the second description when we take y1 and we take y2? So y2 is above y1. So the second velocity is positive, but we want a second velocity to be negative. That's why it cannot be an answer. Because the second part of a motion, the velocity should be negative and decreasing. So means slope should be negative and decreasing. But the second part of the slope, as you can see here, when I draw y1 and I draw y2. So y2 is above y1. So y2 is above y1. It means it is positive. To check the slope, first thing you have to check the nature of the slope. It's positive or negative. So to understand the nature of the slope, you draw the line from x-axis. You will get the value for y1. Then you draw another line. You will get the value for y2. So first part of the motion, the y2 is above y1. So means the slope is, value of the slope is positive. But the second part, when you draw, you got y1 and you got y2. So the y2 is above y1. So again, it is positive. But we don't want positive, we want negative. That's why it's not correct. Why this is not correct? Because it's a straight line slope is constant. But we don't want constant slopes. We want increasing or decreasing slope. What about this one? Again, D cannot be an answer because it's a straight line, means the velocity is constant. If you check this one, y2 is above y1, it means the slope is positive. And what happened to the slope? What happened to the slope is increasing. So it matches with the first description. What about the second part of the motion? The second part of the motion, when we check the nature, that like this is y1 and here's y2. So y1 is above y2. So second part of a motion, it is negative. And what happened to the slope when it is a curve like this? It means the slope is decreasing. So it matches with both description. That's why C will be the right answer. So this was question 14, page 8. Any doubt? Page number 8. Question 18. Acceleration time graphs, okay? It's question 16 as well. Okay. Question 16. A car is moving towards a stop sign at a speed of 25 meters per second. the driver applies the brake 20 meter. So there is a stop sign, which is 20 meters, and the driver applies the brake and decelerate uniformly, and he stopped before the sign. Which of the following give the magnitude of the deceleration? So because he stopped, what is the final speed? The final speed should be 0. Initial is 25 meters per second. So we have initial speed, final speed, and distance. So we can use 2as equal v square minus u square. Or a is equals to v square minus u square divided by 2s. So final speed is 0 square. Initial speed is 25 square and divided by 2, and the s is 20. So it will be minus 25 square divided by 40. So minus 25, because we just need the magnitude. Magnitude means like they bother about the number, not the sign. So 25 square divided by 40. So C will be the right answer. Is it clear? In question 18, value of acceleration is increasing and it is positive. And what happened to the like the value of the acceleration in the beginning? There's a greater acceleration because the change was greater, but with the passage of the time, the acceleration start to decrease as well. Like the change in acceleration is decreasing, not acceleration, the change is decreasing. So when we check which of the following graphs shows how the velocity of an object may vary with time. What about the first one? The first one is actually a deceleration because the velocity is decreasing. So if it was a deceleration, we should take a negative axis. But we are not taking a negative axis, so it means it is not right. Now, what about B? The slope is decreasing, it means the acceleration is decreasing. Why A is not correct? Because A means the velocity is decreasing. When the velocity is decreasing, we call deceleration. Deceleration means negative acceleration. So if it was anything about the deceleration, then we should use a negative axis here. Like the graph should be in this region. But the graph is in the positive axis region. Only one axis is used, so that's why A cannot be an answer. A will be the graph if it was a deceleration. Now, what about B? For B, the slope is decreasing. So if the slope is decreasing, what should happen to acceleration? The acceleration should also decrease. So if acceleration was decreasing, then what should be the graph? The graph which should start with a maximum value. It should start with a maximum value and then start to decrease. But here what is happening? The acceleration is decreasing. But in the graph of acceleration, the acceleration is not decreasing. Acceleration is increasing. How we identify acceleration is increasing? Like here, acceleration is 1, acceleration 2, acceleration 3, 4, 5, and so on. What about C? C means acceleration is constant. So if we have a constant acceleration, because slope is constant, acceleration is constant. So if we were having a constant acceleration, so what should be the shape of the graph? So it must be a straight line, horizontal line, which shows acceleration is not changing. That's why we are left with option D as a right answer, which shows the slope is increasing. So acceleration is also increasing, means the value of acceleration is increasing. Is it clear, this one? Page 9, any doubt? Question 19. A student measure a time for a ball bearing to fall from a rest. So which graph we can plot? We just did now. Like S is equals to ut plus half at square. If initial velocity is 0, so S will be equals to half gt square. So we can compare with the equation of straight line. Y is equals to mx. So on y-axis, if it's a distance, on x-axis, if it's a time square. But we want, if you see which row of a table shows the graph of a gradient will be equals to g. So if I plot this S on y-axis and time square on x-axis, my gradient will not be equals to g, my gradient will be equals to half g. So I want the gradient to be g. Means, so what I have to do, I have to modify this equation in which I wrote half. I have to modify this equation in which I wrote like S is equals to half gt square. If it is like this, the gradient will be equals to half g. But I want the gradient to be g. So if I further simplify, if 2 is divided, other side multiply. So 2s is equals to gt square. So if 2s is equals to gt square, and now I plot 2s on y-axis, and I plot t square on x-axis. So 2s on y-axis, and I plot t square on x-axis. What will be my gradient? My gradient will be equals to g only. If I plot distance on y-axis and time square on x-axis, gradient will be equals to half g. That's why B is the right answer. No, B is the right answer. Question 19, B is the right answer. There is a difference. If you change the axis, like you have this equation 2s is equals to gt square. So you're comparing with the equation of straight line. So you're comparing with y is equals to mx. So on y-axis, if we have 2s, and on x-axis, if I have t square, in that case, only the gradient will be equals to g. But if I rearrange this equation, on y-axis, if I have t square, so the equation will turn out to be like this. And now if I need y is equals to mx, so on y-axis, if I have t square, on x-axis, if I have 2s, my gradient will not be equals to g, my gradient will be equals to 1 over g. So what actually happened, if we change the axis, the gradient will become reciprocal. So when we were plotting 2s on the y-axis and t square on the x-axis, in that case, the gradient was g. But if I change my axis, like t square on y-axis and 2s on x-axis, my gradient will be 1 over g. It become reciprocal. Is it clear? Page 10, any doubt? Page 10. Page 11. 10 party. Suggest why the initial acceleration and average acceleration are different. Look, initially what will happen, this rocket will have some fuel inside. But because what happened, the rocket moved by burning the fuel. So what will happen to the mass of the rocket? The mass of the rocket will change. So if the mass of the rocket will change, we have the formula F is equals to ma, or F divided by m is equals to a. So even though if the resultant force is changing or resultant force is constant, but the mass of the rocket is changing, when the mass changes, the acceleration will also change. So that's why initially it will have a greater mass, so lower acceleration. But as it burned the fuel, the mass of the rocket will decrease the overall net mass. As a result, the acceleration will increase. So the reason why the initial acceleration is different from the average acceleration, because the initial acceleration, the mass is different. Like the mass of a rocket is not constant, it is continuously changing as it burns the fuel, which leads to a different value for acceleration. Page 11, any doubts? Page 11, page 12, page 13, question 25. Which of the following is not a unit of energy? Unit of energy is joules, or we can also say Newton meter, or power is energy divided by time. So energy is power multiplied by time. So power is watt and the time is second. So it can be watt second, or the power can be in kilowatt and time can be in hours. So it can be kilowatt hour. So watt second is there, unit, Newton meter is there, kilowatt hour is there, but Newton divided by second or force over time, it does not give the energy. Like work is force into distance, so Newton meter is there. Power is energy is power into time, so watt second can be there. And it can, if power is in kilowatt and time is in hour, kilowatt hour is there, but A is not the right unit for energy. Page 13, page 14. Any doubt on page 14? Question 31. Okay, 31 and 33. Right. A bus is traveling at a speed of 9. So that's a starting speed. It then accelerates. So this is an acceleration for 8 seconds. What is the final speed? So we use the first equation of the motion, V equals U plus AT. The initial speed is 9. It is accelerating. So we take as positive 0.75 and it accelerated for 8 seconds. So multiplied by 8. So it will be 9 plus 0.75 multiplied by 8. That will give us the final speed of the bus. Which is 15 meters per second. Okay. In question 13, the diagram shows the forces acting on a pitcher, weight W suspended by the cord, and which of the following expression could show the relation between the weight and the T? Look, T is making an angle theta. So T will have two components, one which is with an angle, T cosine theta, and the opposite to the angle will be T sine theta. Same thing for the other tension, the one which is with an angle will be T cosine theta, and the opposite to the angle will be T sine theta. So there is a T sine theta for each chord. T sine theta is acting upward for each chord, the component. So T sine theta and T sine theta is acting upward and weight is acting. So it means the total, because it is stationary, so we can say T sine theta plus T sine theta is equals to W. Or I can say 2T sine theta is equals to W. So 2T sine theta is equals to W. W, it matches with option D. So each chord is having a vertical component. D is the right answer for this. Question page 15, any doubt? Page 15, any part? Part B. Identify the two errors. This is for bouncing ball. Look, the photograph shows student plotting a graph and claim that vertical motion. So the ball is dropped. First mistake. What is the first mistake of the vertical motion? When something is dropped, vertical speed is 0. But if you see the graph, from which point it is starting? It is starting from the maximum value. That's a mistake. It should start from 0. The second thing, when objects are falling for a small distance, they should have a constant acceleration. So if they have a constant acceleration, so means the slope should be same. So as you can see, when the ball is falling, the starting point is different. And the second thing, the slope of this line when it is falling and the second bound, the slope of this line, they are different. They're not parallel. It should be parallel. Yeah, velocity should increase. That's one thing. The velocity should not start from origin, should start from origin like 0, but it's not starting. And when the object is falling, they should have the same gravity, acceleration due to gravity. So they should have the same gradients when falling. They don't have the same gradient. And another thing, it should not rise like point X is shown. When it reached the top again, so this point is higher. Like after the bounce back, it has a higher velocity than when it was. So starting velocity and the final velocity cannot be higher. These are the mistakes or the errors in the diagram. So which is equivalent to Pascal? Pascal is Newton per meter square. Newton is kilogram, meter second raised to power -2, and meter square. So this will cancel. So it will become kilogram, meter -1, second -2. So C will be the right answer for 36. Page 17, any doubt? 17, 18, the last two pages. Thirty-eight. Question 38, it's the same one, which is Pascal. And 40 is a student is asked to solve a following problem. An object is thrown upward. So if we throw upward, what will the final velocity? The final velocity will be 0. This is a starting velocity. How high it will rise? So we need the distance. But in the question, how high it will rise when it is 12. So we have the final velocity, we have the initial velocity, distance is there. Which of the following equation will allow the problem to be solved? We don't know the time, so I cannot use this equation. We don't know the time. We don't know the time, so we can use this equation. How? Because when it is going up, it will have a deceleration, which is negative 9.8 meter per. So we have the final velocity, initial velocity, and acceleration or deceleration. So we can work out distance. Next is question 43. Explain what advantage of using a digital camera compared to that of a ruler and a stopwatch. Like we can determine the acceleration of a free fall by measuring the height and the time, and then we can plot a graph between h is equals to half gt square. We can use that method, but how a digital camera, video camera, will like what advantage it will have if you use a digital camera over this. So first thing, it will reduce the uncertainty. Like because you will have the uncertainties in the measurement. With a digital camera, you can pause the motion of an object, so and you can zoom in, which reduce the uncertainty in the measurements. There will be no reaction time. Yeah, it can be replayed, no reaction time. It can be pause or playback, and we can check the values as well, and we can zoom in to the scale to work out the positions, and we can have more readings in a short time as compared to that of, or simultaneously we can drop different objects from different height and record them, their motions. That can also be done. Is it clear, this one?